Hi class, it's me, Mr. Morris, and we're wrapping up some notes on calculating density. I want to just kind of recap some of what we did towards the end of last class. When calculating density, you need to determine first the mass and the volume, and then we can calculate it. The way that we do this is a few different ways. You can find the mass of a liquid by using a balance, and you take the mass of the empty container. So we did this in a lab when we had a green liquid and the little bitty beaker was the empty container. You put that empty container on the balance and you recorded its mass in a table. And then we added the desired amount of liquid. We poured the little green liquid into the container and we took the mass again. Now we have the mass of the empty container and we have the mass of the container with a liquid in it. The difference between those masses is actually the mass of the liquid, and that's what we're actually wanting is the mass of the liquid. So we do the mass of the liquid and container minus the mass of the container, so we know just the mass of the liquid. Then we said if we have a regular solid, which is not very often in chemistry, but if it were to happen, you can measure the individual sides, something like a cube, and you multiply the three sides by each other, length times width times height. That's how you find the volume of a regular solid. But if you have an irregular solid, which is much more common in a chemistry situation, something like a rock or a bolt or a screw or something like that, a lot of times what we'll do is take a graduated cylinder, like the one you see right here, and we will drop the object inside the graduated cylinder and the water will rise. So however much the water rises is the volume of the object you dropped in. It's the volume that was displaced. So there's a couple volumes we need to measure. Using a graduated cylinder that already has some water in it, we want to record the initial volume of the water, and then we're going to place an irregular solid into the container and record the new volume when we have the irregular solid in the cylinder. Then, to find the object's volume, we will once again subtract. The volume of the object is going to be the difference between the final volume and your initial volume. Now, if you want to do this correctly, you want to read the graduated cylinder correctly. So look at the bottom of the meniscus. We need to look at the increments and figure out what they are. So this is 3, that goes up to 4. So this has to be 3.1 maybe, 3.1, 3.2, 3.3, 3.4, 3.5. No, that did not work because I ended up with 3.5, not 4. So I'm going to assume that this must be 3.2 maybe. 3.2, 3.4, 3.6, 3.8, 3.10, which would be, actually it's not 3.10, it goes up to 4 at that point, doesn't it? So 3.2, 3.4, 3.6, 3.8, the next thing would be 4.0, which is exactly what we have. So that means our volume here at the bottom of the meniscus would be 3.4, but it's exactly 3.4, and don't forget, you always want to go one extra decimal, whether you're estimating, putting a 0. So our initial volume is 3.40 milliliters. And then over here I've got 5, exactly 5. But it's on the same instrument, so I know that I need to have 2 decimals, so I'll put 5.00 milliliters. So to find the volume of the object, I need to do 5.00 minus 3.40. Now let's talk about how to subtract with the correct number of sig figs. This is something that some students had a hard time with. When you're subtracting or adding, we look at the least number of decimal places that are shown. Well, I have 2 decimal places here and I have 2 decimal places there. So my answer needs to have 2 decimals in it. So 5.00 minus 3.40, I end up with 1.6. To make that 2 decimal places, I need to have a 0 after the 6, 1.60. And that would be the volume of the little object that we dropped inside the water. Let's look at a kind of a concept example. Our first example problem. So as a solid object, and we're looking at this black dot here as our solid object, it was dropped in a column of densities. We've got several different densities here. I think this was like 15 grams per milliliter, but it got cut off, and its letter is A. Then B is 8 grams per milliliter, 5 grams per milliliter. You see the most dense is at the bottom, the least dense is at the top. Well, this object, as you can see, it settled between C and D. So what liquids are more dense than the object? You try to answer it first. Pause the video. All right. So the liquids that are more dense than the object will be below the object. So that would be A, B, and C. What liquids are less dense than the object? Once again, pause the video, try it yourself. If it's less dense, it will be above the object, so we have objects, or we have the layers D and E. Estimate the density of the solid object. There's more than one possible correct answer, but go ahead and pause the video and try that. All right, and the way that I think about that, I see that 3 grams per milliliter is less dense, 5 grams per milliliter is more dense. I would probably estimate it as being about 4 grams per milliliter. But as long as it was anywhere between 3 and 5, it is a feasible or a possible, reasonable estimate. Okay, let's look at the next page where we've got some math examples. All right, these are some density problems. Very similar to what you would see on a quiz or test, and you want to be able to solve these. Now it gives us, first, a cube has identical sides at 2.50 centimeters each. What is the volume of the cube? So if I have identical sides, remember that volume can be calculated by multiplying length times width times height. Length times width times height. So if each side, it says that they're identical sides, each side is the same, that means length, width, and height are all 2.50. I can just multiply those by each other. And maybe you recognize that another way of doing this would be to cube that, to do 2.50 cubed. That would work just the same way, but if you prefer and feel more comfortable, just always do length times width times height so that whether they're the same number or not, you'll always get the right answer. I get this answer. I want to round it to 3 significant figures because I'm multiplying and I want to keep the least number of significant figures when I'm multiplying. So that's 15.6. Centimeters times centimeters times centimeters would be centimeters cubed. 15.6 centimeters cubed. And the reason I said that is because, well, I wrote that kind of wrong. Let me correct it. Centimeters cubed. There we go. The reason that I say that it's centimeters cubed, again, I took this number and these units and multiplied them by themselves 3 times. Centimeters times centimeters times centimeters gives us centimeters cubed. 2.50 times 2.50 times 2.50 gives us the number answer, 15.6. All right, now it tells us that the cube has a mass of 15.0 grams. We're talking about the same cube because it's the same problem. It says, what is the density of the cube? Now, when you're doing your density problems, I want you to do a couple different things to get full credit. This way I can give you partial credit if you're on the right track, but you don't quite know what to do. So, to start with, I want you to label your variables. What that means is we know the formula for density is D equals M over V. So we're going to list density, mass, and volume over here. Density, mass, volume. By the way, this will prepare you for physics. They use something called the guess method in physics, where they want you to label your given, your unknown, and then your equations, and to solve it and write your solution at the end. So it's important to go ahead and practice that in chemistry so you're more ready for it next year. All right, 15.00 grams, that is a mass. So I'm going to put that right here, 15.00 grams. I'm looking for the density. It's the thing I don't know. And my volume, well, we found it up here. You see volume equals 15.6 centimeters cubed. So now what I want to do is just solve it by plugging everything in. Since I don't know what D is, I'm going to leave it as my unknown. D equals 15.00 over 15.6. And then I can put that in my calculator and find the answer. Since I'm doing grams divided by centimeters cubed, my units will be grams per centimeter cubed. Now let's plug it in the calculator. 15.00 divided by 15.6. I get 0.961538 and so on. I only want, well, this is 4 significant figures. This is 3. I want to keep the lower number of significant figures, so 3.96. The 1 rounds up because of the 5, 0.962. Grams per centimeter cubed. And then finally it says, would the cube float or sink in water? And it tells us the density of water is 1.00 grams per centimeter cubed. So the question is this more or less dense than water? It's less dense. So it would, if it's less dense, it would float on top. There you have it. Okay, let's do another example. The density of gold is 19.32 grams per centimeter cubed. That's our density. What's the volume of 100.0 grams of gold? Now it tells me 100.0 grams. I hope that you can recognize that grams, if you look back at our units on the second page of our notes, grams are a unit of mass. Okay, so you need to watch out for your wording here. Sometimes it doesn't tell you what it is, but grams is a unit of mass, so I know that's M. Okay, my density, D, and what I'm looking for is V. Okay, so let's label it. By the way, I will give you partial credit if all you can do is label the variables, as long as you label them right and put your units. Density, mass, and volume. So my density is given as 19.32 grams per centimeter cubed. My mass is given as 100.0 grams. And I don't know the volume, but I know that because I have centimeters cubed right there, my volume will be centimeters cubed. And I also know the equation is D equals M over V. So let's plug it all into the equation. I have 19.32, that is my density. 19.32 equals, and then M is 100.0. 100.0. And then I have volume, that's my unknown on the bottom. Now, I hope you remember from algebra, we cannot solve for x or for any unknown if it's in the denominator. So I have to get that out of the denominator somehow. The only way to do that is to multiply by v on both sides. So that's what I'm going to do. I'm going to multiply by v because I'm doing the opposite of what's happening right now. It's division. The opposite of division is multiplication. It's opposite operation. So I'm multiplying by v on both sides, and I hope you see that that cancels out the v on the right side, and I end up with 19.32v equals 100.0. Now I'm multiplying by v. If I want to get v by itself, I would have to do the opposite of multiplication, which is division. I'm going to divide both sides by 19.32. So I end up with v equals 100.0 divided by 19.32. And then in your calculator, you can put that in 100.00 or 0.0 divided by 19.32. I get 5.175 and so on. I just want 4 significant figures, so that's 5.176. 5.176 centimeters cubed. Okay. Got another problem down here. An empty graduated cylinder has a mass of 89.75 grams. A 5.00 milliliter sample of liquid is poured into the graduated cylinder, and the mass of the cylinder and liquid is this. Now I see masses. I see 2 different masses. Well, the first mass is an empty graduated cylinder mass. The second mass is the mass of the cylinder and the liquid together. Then it says, what is the mass of the liquid? Okay, to start with, the liquid has a mass of the difference between those two. This is the mass of the cylinder and the liquid. This is the mass of just the empty cylinder. So the mass of the liquid equals 98.46 grams. The mass of both minus the mass of the empty graduated cylinder. This is just like the green liquid that we did in the lab. We want to round to 2 decimal places because that's what is given, and we're subtracting. .71 grams. Okay. Then it says to determine the density of the liquid. Well, to find the density, I have to have mass. So I'm looking for density. I have to have mass and volume. Well, I found the mass to be 8.71 grams, but what about the volume? Look back at your problem. 5.00 milliliters is the volume. So density equals mass over volume, mass being 8.71, volume being 5.00. 8.71 over 5.00. To 3 significant figures, that would be 1.74 grams per milliliter. Okay, next we have a piece of aluminum is dropped into a graduated cylinder filled with water. The volume of the cylinder rises from 25.3 milliliters to 34.8 milliliters. What's the volume of the piece of aluminum? So to start with, let's find the volume. I have 2 different volumes given, the initial and the final being after I've dropped something in it. So it rose when I dropped the aluminum into the graduated cylinder that was filled with water. So I need to take the final volume minus the initial volume, 34.8. So V equals 34.8 minus 25.3. We get 9.5, 1 decimal place. 9.5 milliliters. Then it says if the density of the aluminum is 2.71 grams per milliliter, talking about the same problem, what is the mass of that piece of aluminum? So now we have to label our variables again. There's not a lot of room here, but we can do it. Volume was given as 9.5 milliliters. The mass is what I'm looking for, the number of grams, and the density is 2.71 grams per milliliter. Okay, let's set up our equation. Density equals mass over volume. So I've got 2.71 equals mass is my unknown over volume, which is 9.5. Now, if I want to solve for mass, it's already in the numerator. I just want to get it by itself. Well, how do I get it by itself? Right now, I have mass divided by 9.5. I want to do the opposite of that. I want to multiply by 9.5 so I can get rid of that 9.5 and have m by itself. So I'm going to multiply both sides by 9.5. If I were to multiply both sides by 9.5, this cancels out. And then over here we end up with mass equals 9.5 times 2.71 and I get 25.745, but I only want 2 significant figures, so that rounds up to 26. Grams. All right, that's it for density. Spend a little time doing the practice on density.